When we talk about fundamental trigonometric identities, we want to first understand what it really means to be an identity. Um, an identity represents an equation for where every value supplied works. So that's different than in just an equation, and I'll explain why. Um, so if we consider x squared minus 4, so just little parabola, um, we know no matter what, because of factoring, no matter what, this is always the same thing as x plus 2 times the quantity x minus 2. This is always true. We could replace one with the other at any time, no matter what, um, because it's always true. And so this is an identity. Now, if I were to say something like x squared minus 4, I could have this equal anything, 17 if I wanted. But this is just an equation because it's not always true. I could think of x values where this wouldn't work. Now there are x values where this will work as well, but not always. That's the difference between an identity and an equation. An identity, we can change them out at any time because they are the same for every value of x. Now, when it comes to trigonometry, we have 6 major ones that we want to talk about. The first one refers to, let's say, secant. The secant of theta. Well, this is always the same thing as 1 divided by the cosine of theta. This is something we worked on a little bit. So if we can identify cosine, then we can also identify what secant is, just by doing its multiplicative inverse, just by its reciprocal. So those two are tied together. We also know that cosecant is always going to be 1 over the sine of theta. We can replace one with the other at any time for any reason that we want. You'll see that oftentimes it makes sense to pick one version or the other depending on what kind of problem you're dealing with. The next two that we're looking at refer to tangent and cotangent. Well, tangent of theta involves not just the sine but the cosine. Tangent of theta is always equal to the sine of theta divided by the cosine of theta, always. So tangent behaves interestingly. It behaves different than sine and cosine because it's a ratio of the two. And lastly, the cotangent of theta equals the cosine of theta divided by the sine of theta. So these we've already been kind of going over, but these are identities. These are the same no matter what, and we can replace one with the other whenever we want. So don't be afraid to do that. And in this section, you're going to have to be able to think about both of these and which one should I use in certain situations. Okay, so these are 4. Now, the next 2 that I use are derived based on an idea about how triangles work with trigonometry. So consider, for instance, that we have a point here on a unit circle, so we know that its radius and / hypotenuse is 1. Well, the cosine represents the x-coordinate, and the sine represents the y-coordinate. Okay? So if we think about this, we can build a triangle from this. So like our cosine represents x. Well, that's the same thing as the x down here, right? So this is the same thing as cosine of theta. Our sine represents the height here, how high up we are. This is the sine of theta. Well, if we link this with something that we've used before, the Pythagorean theorem, we can create a new identity. It's called the Pythagorean identity that says that no matter what, because we know this represents a right triangle, we can say the following always, that the cosine squared of theta plus the sine squared of theta equals 1. Always. That has to do with the fact that we know that a squared plus b squared equals c squared when we refer to right triangles. Now in this case, a represents cosine, b represents sine, and c represents 1. 1 squared just being 1. So this is a really powerful identity that we're going to use quite often throughout trigonometry. So please keep this and make sure you write this and put a star by it, whatever. But this is something we will come back to constantly because it's the basis of most trigonometric identities. Now, the other two are based off of this formula as well. So what we can do is we can consider the same formula. So cosine squared of theta plus the cosine squared of, or sine squared of theta, sorry, equals 1. Well, if I can divide each side of this equation by cosine squared. Now that seems kind of odd. Why would I do that? But it creates something brand new, and that's because of those other identities that we looked at on the previous page. So if I were to say, okay, well, let me divide this by the cosine squared of theta. If I divide that by cosine squared, I have to divide this side to be even, and then I have to divide this entire side, which is just this term, by cosine squared as well. Well, this creates a brand new identity. If we simplify this, well, the cosine squared of theta over the cosine squared of theta is just 1. Now, if we think about from the previous page, we can figure this out. Sine squared divided by cosine squared. Okay, think about what sine over cosine is. Sine over cosine we found was tangent. So sine squared over cosine squared is actually tangent squared of theta. Now that's going to equal 1 over cosine squared. Well, we learned that 1 over cosine previously was the same thing as secant. So 1 squared, which again is the same thing as 1, over cosine squared is going to be secant squared. So this is the second identity. Okay? So let's see, we're going to call this the first one. This is the second one. And now I'm going to do a third one. So but let's go back to this middle part. And I'm going to change this around. Instead of dividing by cosine squared, I'm going to divide by sine squared. So now I can create something brand new as well. Cosine squared divided by sine squared. If we think about what cosine over sine is, that's cotangent. We get cotangent squared. Sine squared over sine squared, just like in the problem before, it's the same thing over itself, so is equals 1. And then finally I have equals 1 over sine squared. Well, 1 over sine is cosecant, so 1 squared, which is still 1, over sine squared is cosecant squared. So these three formulas are all based on the same idea of using a right triangle and thinking about the Pythagorean theorem, but by extending that towards the unit circle and the idea of that the sine and cosine represent coordinate points on a unit circle. And we can also think of those as triangles. So these three identities and the four previous in the other page are going to be used constantly. And these are the only ones that we're going to use throughout this entire section. And we're going to use them in a bunch of different ways. So we want to make sure that we can understand what an identity is. That if we can, one side is always equal to the other. So we can replace them whenever we want, and we can replace different forms of them if we alter them legally. So please make sure you write these down and always reference these during this section to make sure that you're inputting the right stuff.